Hi, Josh. Uh, you'll be proving three problems about medians and the centroid of a triangle. Number one, prove that the medians of a triangle are concurrent, meaning they intersect or meet at one point only.
So one important theorem I will be pointing out before we prove this is CEVA's theorem. And it's Converse. So I will present you grades. So A, B, C, D, E, F. So Chevian is a segment, or Sevian is a segment from one vertex of a triangle to the opposite side. So Cheva's theorem states that if all three segments of a triangle are concurrent, then this is an equation we will arrive to. This is AE times EB
Over EB
over EB
times
times BF over S is this is all equal to 1. And its converse states that if we know that this equation is true, then therefore all three trivials of that triangle are concurrent.
concurrent. So here, in order to prove that the medians of a triangle are concurrent, you will
I will probably use its converse because the converse will be able to tell us that the trivials are concurrent. So a median is a trivian, but the opposite side is bisected by that trivian.
meaning the opposite side will have two
Two equal
lengths.
lengths.
It will be divided into two equal lengths.
So tick marks. Okay. So if we can prove that AE over EB is times FB over wait, BF maybe to make it better. FC times CD over DE is equal to 1. Then we can prove that the medians are concurrent. Since AE is in the figure shown to be equal to EB, then this will equal 1. And BF is also tick mark to FC.
One.
Yes, AE over EB is the same. So if they are the same, their quotient is 1.
Yes.
BF over FC is also 1 because they are congruent. Similarly, CD is congruent to DA, so therefore its quotient must be 1. And 1 times 1 times 1 is obviously equal to 1. So therefore, all three medians of a triangle are concurrent.
So, and then what do you call the point B where
So the concurrence of
Point
all
of
three
concurrence.
point of concurrence of all three medians of the triangle is called the centroid.
centroid? Yes.
If
So,
you make
point A is the
yes,
centroid.
if you make a sheet of paper and then a triangular piece of paper and then label its centroid, if you put it on a pin, it will balance because the centroid is the center of gravity.
Yeah. Okay, let's proceed to number 2. But we will be using, are you going to use the same figure?
Yes, I'll be using the same figure.
Okay. So,
So, quick sketch. Horizontal enough. When it glitches, it means it's horizontal. There. And then, oops, I didn't mean that. Select everything. Where is the squish? Yeah, how do I squish it? E. There, looks good.
So
Then,
number two, prove that the medians of a triangle divide the triangle into six triangles with equal area.
so, even just with eyeballing, you can already know that they are approximately concurrent. Here, I'm only eyeballing what seems to be the midpoint. This seems to be the midpoint. Without even looking at the others, that seems to be the midpoint.
Nice.
And it just seems to be the midpoint, but they are already obviously concurrent.
The midpoints.
Yes, wait. The, mhm. What was the one I was using before? Okay, switch them. This is what? G. Let's try.
The centroid.
Okay, so I will prove one case first. So maybe we will prove it with the already upright. Well, while it's already upright, so we don't have to flip it. So I will highlight the triangle AGB.
In the congruent lengths.
Yes. Ah, almost perfect. So G G D A, and then I have somewhere there. There. Okay, so there's congruent, 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 congruent. So here, I will first mention the area of a triangle is 1/2 base times height. So let's say there are two triangles with the same base and same height.
So this is the follow. The,
If they have the same height and the same base, then their areas are equal. This also applies
the
to
base.
yes.
With the bracket. So that's the base. Base.
This is the height.
Same base.
So
same
yes,
height, so they will have equal area.
if two triangles start from the same height, I say vertex, then obviously their height is the same. So here, two triangles AFG and FGB with AFG, 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 and oh, it looks blue
This is two.
there, and FGB, and FGB. They have congruent bases. It doesn't have to be actually the same base as long as the base is congruent. And they have the same height. Where's the light blue? Yes. Their height is also the same. Equal heights
Same height and equal
and
bases. Same height,
have same height.
same height, exactly the same height. And
I mean, they have the same altitude and
equal bases.
equal basis. So therefore, the area of AFB is equal to the area of FGB. Similarly, I will again highlight, yes,
Follow this one if you want.
you know. Hmm,
This triangle,
this triangle,
that's the same area as this triangle.
yes. So,
Similarly,
similarly, oops, still not locked. Similarly, similar. Similarly, the triangles CGD and GDB. I write it wrong. CGD is equal to
it's the same area.
GDB.
GDB.
It's just flipping.
Yes.
So, something that
CB is
really
there. Is the base there. Okay. That's a small triangle and this small triangle have equal area.
And then also,
Similarly also,
maybe I should write this in their colors. Anyway, never mind.
yes,
E, E, G,
you can write them in their colors.
um, E, and maybe this one. I haven't used this one. Thank-
Yes. Yes. But now, are the areas of what?
Yes, so I will scale it down a bit because there are in a circle. Why does Zoom hate parallels? Okay, so that was very perfect. Exactly how I hoped it would come out. And then, I'll just move this up here. C, G, F, B. So again, same height, where's the green? Same height, same base. No, not same height, congruent bases, equal bases. Therefore, E, C, F, area of ACF is equal to area of BCF. Similarly, what? I'll just write it in red. So it will, there's no, I will write in ACF is equal to, no, not ACF. I just wrote it again. AEB is area of AEB is equal to area of CEB and area of yes.
And for BC, when BC is the base, ABB was went to ABC. Yes.
Yes. So because of this, put the next page.
Next page.
Now I will integrate both triangles. Actually, all four triangles. Median somewhere here. And then I'll just draw the median so I can. And then I will just erase them. Okay. Nice. Okay. Exactly what I was hoping for. G. Why did I write it like that? G. Centroid. F. This is ABC.
Yes.
Yes. Okay. So let yellow area, which is AFG. Oops. Equal X. Let purple, pink area, fuchsia area. Let's, what's that? CGB. Oh no, BGD. Equal Y. Yes. BGD. And CED. Yes, correct. I thought I was wrong.
To show the detail, we're using the
CGE.
Is it only up here? Is that what you would know?
Hmm? Yes, only one small triangle.
Okay. And the whole of
Only one small triangle of green. I should draw it less like that. No. So it will be more obvious. Only partially. Because maybe you will think that I met the whole area. It's only one small triangle area.
they can understand it as long as you label a triangle.
Okay.
You label the triangle on the other page. Because we
AEG.
use these.
Yes, right. This is mm, mm, So this will be x, x,
Okay.
y,
Now we can understand.
z, z. Yes. Okay, so this will be y and y, z and z, x and y. So earlier I proved that. What did I prove earlier? I remember an ACF, BCF. Yes. So ACF, BCF, ECF, BCF. So this is x plus 2z. Let's wait. Maybe.
Yes.
And um, um, 2 is equal to x is to y. Then, therefore, 2z is equal to 2y. Therefore, y is equal to z. Okay, so now we just prove this.
The yellow.
Yes, wait. I'll just make a quick scan.
Yellow.
Yes, wait.
You got why?
Ano, the purple, the pink, first markup,
yes, pink and
and the spring green.
so one pink triangle has an equal area with that of the green triangle.
Now, what will be the dominating word? Let's say green. Similarly, oops, forgot to switch. Similarly, what can we use? We can use any.
When see
Maybe AEB, CEB. Yes, AEB, CEB.
when AC is the base.
Yes, AEB to base AEB, CEB. So this is what this is. B plus 2x is equal to z plus 2y. So therefore 2x is equal to 2y. Therefore x is equal to y.
So particular X is
Yes. So now
the X how you wrote the X.
yes.
X.
And this is
So X equal to
so therefore our entire triangle
one yellow triangle has an equal area with that of pink triangle.
will just put the medians.
Or
The entire area is now x. This was x z z. Maybe it should
or
be.
it should be Y.
It should be.
All Y.
No, it should be all yellow.
No, you equated both to pink as Y.
Ah, okay. So I will have to use a different.
No, it's the same.
No.
Just Change the variable and color.
Oops. Thankfully, there is Control Z.
So you equated there, the the z's are equal to y, so they're all y's.
And then now X is equal to
You
Y.
equated,
So they're all X's.
they're all x's or they're all y's.
Yes. So what is the goal of the problem? The goal of the problem is prove that the medians of the triangle divided into six triangles with equal area.
Yes, therefore,
This is X. Yes, QED.
yes. So
What error number is that?
proven, yes. Nice.
Nice. Okay. So let's do our next problem.
Number 3 of school, we can prove that the centroid of the triangle cuts each of the triangles median into 2:1 ratio. Centroid
yes.
is the point of intersection of the three medians of a triangle.
So let's use AVB in this same figure. Yes, and then okay.
The vertices
Wait,
first.
wait. Oops.
So,
Okay.
the centroid
So here we already proved something. And
wait,
okay. It's like gamma.
y, y, yes, y plus y.
This is
If you use y now, it's about
oh wait, no, it should be X.
I can check it again.
The yellow stands for
Yes,
X. Stands for X.
2x, x.
There. Clean.
That is x.
Okay, so now, is this obtuse? Yeah, it looks a little obtuse. So, mm, mm, oops, you do. Never mind. Doesn't want to exist. Uh, here. I can't use a tool with a dotted line. You should add the tool, a line tool with dotted line. Okay, so they have the same height. Obviously, they come from the same vertex A. So here, ABB has same height as GBD or DGB. There. Okay. AGB, AGB. This is AGB is oops. Maybe a more, so I was a little, maybe I could have used this instead. Maybe this height instead. Yeah, so now it will be more apparent. So we're going to prove that this is 1 and this is 2. These are its proportions. 2 times area. So if AGB is 1/2
What is one?
B of AGB, this is AGB. I'm going to put it times height equals 1/2 base of AGB.
The area. Is equal to twice the area of GB.
Answer. So therefore, if AGB is still twice DGB, therefore the base of AGB must be twice that of the base of DGB. So what's the base of AGB here? It is AG. AG is equal to 2 times GB.
The two, the
Ano?
second row,
Uh,
because this one, it really appeared to. Yeah.
oh wait. Yes. Okay. So AG is equal to DG. Similarly, what are the other medians? EGGD, BGGE, BG is equal to 2DE. And, oops, CGGS. So yes, and that's written in a 2:1 ratio.
Yes.
Yes. Okay.
Hope you like the solutions of GeoGebra and you
Yes.
learned something from watching our video.
Thanks for watching.
Thanks for watching.
Bye.
Sign out.